Okay, today we're going to look at section 7.7, which is talking about odds. Now, odds are related to probability, but they're not quite the same. Particular lottery instant win game has 2 million tickets available. Of those, 500,000 win a prize. If there are 500,000 winners, then it follows that there are 1,500,000 losing tickets. When we evaluate the risk associated with a game like this, it can be useful to compare the number of ways to win the game to the number of ways to lose. In the case of this game, we would compare 500,000 wins to 1,500,000 losses. In other words, there are 3 losing tickets for every winning ticket. Comparisons of this type are the focus of this section. So, how do we compute odds? The ratio of the number of equally likely outcomes in event E to the number of equally likely outcomes not in the event is called the odds for, or the odds in favor of the event. The opposite ratio, the number of outcomes not in the event E to the number of in the event E, is called the odds against. Both odds and probabilities are calculated as the ratios. To avoid confusion, we will always use fraction decimals or percents for probabilities, and we'll use colons to indicate odds. You've probably seen this, especially if you're a football fan or something of that nature, or a gambler. Rules for simplifying fractions apply to odds too. Thus, the odds for a winning prize in the game described in the section opener are 500,000 to 1,500,000, or 1 to 3. And the odds against winning a prize are 3 to 1. These would often be described in words as the odds of winning are 1 to 3 in favor, or the odds of winning are 3 to 1 against. Notice that while probabilities must always be between 0 and 1 inclusive, odds can be any non-negative number, as we'll see in our next example. So you roll a pair of 4-sided die with faces 1 through 4. What are the odds of rolling a sum greater than 3? Well, if you recall, the number of equally likely outcomes in the event was 16, and the number of events that's the sample space, excuse me, and the number of equally likely outcomes in the complement were 3, which means the number of likely events in E is 16 minus 3, or 13. So our odds would be 13 that we're going to get a number larger than 3, and 3 that we're not. Okay. What are the odds against both dice getting the same number? Well, there's only 4 ways that both dice can get the same number. 1, 1, 2, 2, 3, 3, and 4, 4. So the number of outcomes in the event is 4, and the number of outcomes not in the event would be 16 minus 4, or 12. Now we want the odds against the event, which means the number of outcomes not in the event, 12, and the number of outcomes in the event, 4. And then just like a fraction, we can reduce this to 3 to 1. So now let's talk about odds as a ratio of probabilities. You can also think of odds as a ratio of probability. Consider, again, our instant win ticket game from the section opener. With 500,000 winning tickets out of 2 million total tickets, if a player buys one ticket, the probability of winning is 500,000 over 2 million, or 1/4. And the probability of losing is simply 1 minus 1/4, which is 3/4. Notice that the probability of winning to the probability of losing equals 1 to 3, which matches the odds in favor of winning. Then we have a couple formulas here. The odds for E equals the number of outcomes in E to the number of outcomes in E complement, or the probability of E to 1 minus the probability of E. Likewise, odds against E is 1 minus the probability of E, or the probability of E complement, to the probability of E. So let's see how this works. We can use these formulas to convert probabilities to odds and vice versa. If the probability of an event is 80% for and the odds, find the odds for and the odds against. So if it's 0.84, that means it's 0.2 against, or 0.20 against. Or it's 8 to 2, 4, which would be 4 to 1. And against would simply be 1 to 4, the reverse of that. We can also convert odds to probability. Let's say the odds for an event A, for an event are A to B. And using the formula above, we have A to B equals probability of E to 1 minus the probability of E. Converting our fractions, we eventually get the probability of E equals A over A plus B. Okay? So there's our formula. So the odds of E are 15 to 1. AB. Find the probability of E. So it would be 15, 15 plus 1, 15. But that's against, and we want 4. Or that's 4, and we want against 15 over 16, so 1 over 16. The odds of E are 2.5 to 1 in favor. So I want to find the probability of E. So again, it would be A 2.5 over A plus B, 2.5 over 3.5, 25 over 35, 5 over 7, which is roughly 0.714. Some places, particularly state lottery websites, will use the words odds and probability interchangeably. Never assume the word odds is being used correctly. Compute one of the odds probabilities yourself to make sure you know how the word is being used. Okay. And that finishes up this section.